So in this way, the properties or the instances what we create is considered as a object. Once a object is created, then that class will be provided with a memory. The thing to be noted here is each and every object has its own independent data set which it has to be followed. We are creating an object with sample of followed by returned object equals object.get. Hello everyone, I welcome you all to the third session of Unit 3, which is all about classes and objects. So this is with respect to Python programming and the subject is all about fourth semester. So over here, my name is Deepa Kutnikar. I'm working as an assistant professor in the Department of Computer Science, Vidhyaashram, Temple of Excellence, MYSURU. So let's move forward and understand what is the agenda of today's session. So in today's session, we will be discussing like what is a class and what is the objects, then how those objects and classes can be created, then how the classes can be created with multiple objects and objects has reference. So there are various things to be understanding regarding a class as well as object. Then further we will be also discussing the constructor, like what is a constructor and why we are studying this constructor with respect to object in the class. So all these things we'll be discussing over here in today's session. Then what are the types of constructors? So yes, we will also be dealing with this today. Up next, we will also be learning with respect to inheritance. So inheritance and its types. So these are the things that we discuss in our today's session. So let's start with a class. So yes, class is nothing but a simple template or a blueprint of any of a object or any of a things. So now let's understand what is an object. Object is nothing but an instance of a class, or we can say that the various members of class will be considered under the objects. So let's consider this with an example that if we consider a classroom has our class, and what about the object? So with respect to objects, we can consider the number of students, the number of benches, number of bags, as well as the number of ACs inside the classroom, etc. So in this way, the various class members will be considered under object and that complete thing can be defined as a class. Clear? So now we have one more example over here. So we can see that this car is considered as a class. Okay. And what about the other things? So with respect to car, we have multiple properties of it, like what is the color of that car, which is the make and the model of that car. So all these things will become a object of that class. So if we consider this class has a car, then we have multiple cars here, correct? So for that multiple cars, we can define its objects or the instance. Or we can also say that the behavior can be explained in depth with respect to the object. So we can see that the color can be explained and the make or the model of that particular car can be considered as an object. So up next, we can see that the next car is of blue color and the model is a Toyota. Similarly, the next color of the car is a green one and the model is Volkswagen. So in this way, the properties or the instances what we create is considered as an object, and a thing or a blueprint, whatever we consider, it is termed as a class. And what about these things? So these things are termed as objects. So a class and an object. Let me tell you one more thing. Inside the memory, the class will not be allotted until and unless these objects are created. Clear? So the main thing that is required to make a meaningful class is an object. Understood? So correct, right? So we have to define in particular like what is its make and what is its color and the remaining properties, so that it will be very feasible to go forward with the class. Correct? So once a object is created, then that class will be provided with a memory. Unless and until an object is created, the class will not be allocated inside the memory. So this is the main thing to be noted. Clear? So this is a basics of a class as well as an object. Understood? Great. Let's move forward. Now let's see how to create this class as well as object. So in simple way, the class is created with a class keyword followed by its name. Okay. Then the object can be created by a init keyword. So this is utilized to create a basic new object. So it is used for creation of new objects. So let's see an example here. We have a class followed by a student, right? So this class is a keyword and this is a class name. Then we are defining. So what is that? DEF, defining that display of self. Great. Then we are writing a print statement. This is a student class. All right. Now let's move forward and see how the object is been created. It can be easily created in this way by assigning object as student of, where we will be displaying the various characteristics of that student, like a student name, his roll number, then the gender of that student, then the mark score. So in this way, various properties of that student can be noted under the object. Clear? So once this object is created, then we can say that a class is a meaningful and a memory will be allocated for that class. So now lastly, we want to display that object. So at the output, we can see that this is a student class. So this print statement, so inside the print statement, whatever we have written, it will be displayed after execution of this code. So this is a simple thing, that how the class as well as an object can be created inside a Python programming. So now let's go forward and understand how the class with multiple objects can be created. So first let's understand what is this, then let's move with an example of creation of this class with multiple objects. So creating a single class with multiple objects is a primary method through which we can expect that the scaling of applications can be done, as well as modeling of complex systems will also be a valid one. Okay, so we can say that once a single class is created, under that we can go forward with creation of multiple objects. We can say that inside a class, a multiple object can be created. So what is the mode of creation of multiple objects? It is very, very simple. We want our code to be very concise one, and the complex problems can be scaled in an efficient way by using that object class relationships. So let's see that we have learned it in our example, correct? So for a single class, we have created multiple objects, like we can consider this as car 1, car 2, car 3, or first car, second car, third car, anything. So with respect to that car 1, one object will be created. So this is the second object and the third object. And with respect to each object, the various properties of that car can be printed or scripted, correct? So in this way, what we can say, the complex problem can be scaled in a very efficient way by using a class as well as a object relation. So this is how we can move forward with creating a class with multiple objects. Clear? The thing to be noted here is each and every object has its own independent data set which it has to be followed, right? So if we consider that same example, we had 3 different cars which we might consider as object 1, object 2, object 3. So object 1 has its own properties, next object 2 has its own properties like color, model, make, etc. Similarly, object 3 will have its own properties, right? So these properties are independent and it is related to the main class, correct? So this is how we can go forward with creation of multiple objects inside a single class. So let's move forward and understand the example here. We are again considering a class of student. So this is the class that we are defining. Now with respect to that, we are defining the self properties, then we are printing student object created. So how many times the same object has to be created? Let's see. It depends on the object definition times. So we have S1 student of, S2 student of, S3 student of. Next, what we have to go with? We have to show that statement, correct? So how many times or the multiple object creation with a single class is defined by using this S1, S2, S3. Now it has been displayed by this S1.show, S2.show, S3.show. So this completes our program, and after execution of this program, at the output, we will be seeing that according to a single object, we have our output that has to be executed. So what it has to show? The student object is created. So same thing, correct? So how many times? So it depends on the number of times of objects that we have considered. So we have considered 3 of the objects, so it will be repeated for 3 times. So this is a simple example with respect to creation of class with multiple objects. So the next thing that we learn here is object has argument. Till now we did understood what is a class, what is the object, how to create a class and the object, and what are the relation between them. So it's done. Now we know that we can create multiple objects under a single class, right? So in any case, if we want information from that intermediate objects, because each object will be having its own independent values, correct? So if we require that information, so what has to be done? So at that time, we can pass the argument. So that's what object has an argument. So what does argument will help? By passing object has an argument, we can go with carrying the information or accessing the information from multiple objects that are being created. So if I consider that S1, S2, S3, so these 3 are the objects that we are considered. Now within these 3, let's say S3 needs some information from S1. Okay, so will this be possible? Yes, we can collect the information from S1 and we can pass it to S3. But to do this, the thing which helps us is arguments. Arguments will help us to access information between the objects, so that it will be very, very easy for accessing data from another object, facilitating the complex interactions between the object-oriented programs. Clear? Thus, we can say that passing an object has an argument is a fundamental practice for enabling communication between the different parts of a program. All right, let's move forward and let's see an example for this. We are defining a number. So a class with number is defined. Further defining the value self comma n, it has to go with a number assignment. So self dot number is been assigned with a value n. Similarly, let's consider defining a display of object, and a print statement for print number is object dot number. So this object number has to be printed, right? So now n1 equals number of followed by n1 dot value of 10, then display of n1. So we can see here we need a object dot num, but where is that object dot num? It is been created in the next part where we have n1 defined as number, and that n1 dot value, what is its value? 10, right? So this 10 is to be accessed by the main object. So let's see, is it possible? Yes, after execution of this program, at the output we can say that number is, so what is the number that we have defined in different object? That is 10, which is accessed through the argument. So that is a 10 value which has been displayed. Up next, let's see how an object can return a value. So it is none other than objects has return values. Returning an object from a method or a function is a standard way to facilitate the data flow and creation of new data structures within the programs. This allows the method to generate, transform, or to filter the complex entities and hand them back to the caller, shows that the object reference is returned. Let's say an example here, we are defining class sample followed by get of self, and we are writing a return statement, return self. Now we are creating an object with sample of, followed by returned object is equals object dot get. So that is the get function what we have defined in a main object, correct? Now we can write that print returned object, followed by, at the output we can see that after execution of the simple program we will be getting that main sample object at 0, which shows that that object is been returned back. Okay, so this is how we can consider a object has a return value. Now let's start with constructor. So we have completed understanding with respect to class and the object. Now we are heading with a constructor in Python programming. In Python, we can consider a constructor has a special method that is being created automatically or called automatically whenever a new class is being generated or created. The primary goal of this constructor is to initialize the object's initial state by assigning values to its attributes. So don't get confused. This is very, very simple. We can see here we started our learning and understanding with a class, then followed by object, and then we are moving with constructor, correct? So now we know that this class is the initial thing or a blueprint, correct? And now until and unless this object is created, the class won't get the memory, correct? And once this object is created, then the memory will be allocated. Further, the constructor. What about this constructor? So this constructor is assigned automatically or created, or it is being called whenever a class is created. And the main thing to note here is the class as well as the constructor is both related with object. Only when the object is created, then the class will get the memory access, and only when the constructor will allocate or the constructor is initialized, at that time the object initialization is done by this constructor. So how is it done? It is done by assigning few values for its attributes or properties. So this is the criteria. That is, first one is a class, then a object, then followed by a constructor. Now let's see what is the types of constructors that is available in Python programming. So there are two different constructors. First one is a default constructor. Next, second one is a parameterized constructor. Thus, let's move forward with a default constructor. As the name itself says, default constructor. So this is called defaultly, and the values are initialized, the assigning of values. If it's not done by a user, then the system defaultly assigns those values through this default constructors. Okay, so let's see an example class demo. We are defining init of self, where we are writing default constructor called. So that is the print statement that has to be printed after execution of my program. So next, what I am seeing a creation of object followed with a demo name, correct? Demo of, done. Now with respect to output, we can see that default constructor called. So in this way, if we consider any of the example with a values, and in that value, if a object is been created without any of the values, then the system itself automatically gives or initiates the values by default, and it is none other than a default constructor. Clear? Let's move ahead with parameterized constructor. Parameterized constructor is a specialized init or initialize method that accepts the arguments beyond the mandatory self-references. So there might be some references which are fixed, and if a user wants to add next few of the values or the statements, yes, then that things can be made possible by this parameterized constructor. The primary goal of this parameterized constructor is to initialize new objects with specific or custom data at the moment of creations, ensuring that each instance will have unique attribute values. Let's say example, we are considering a class of student followed by defining init. As we know, it is a special method, correct? So define init of self comma name, Then we are writing self.name followed by name and printing a statement where student name equals name and yes equals student. So is name, we are writing his name or defining his name. Great. At the output, we can see that student name equals Amit. So this is how we can collect the information from one object to other. We can access the information and we can show it during execution. So this is a second type of constructor, that is none other than parameterized constructor. So we are done with constructor. Let's move forward with inheritance. Inheritance, as we know, it is a basic principle of OP concept, right? So let's understand what is this inheritance all about. Inheritance allows a child class to be created with various attributes as well as behaviors which are derived from the base class, or we can also call it as a parent class. Okay, there will be something called as parent class or base class, and then followed by the newly created classes are considered as a child classes. Clear? In simple way, what we can say here is a new class will be generated or derived by acquiring the properties or behavior of another class. So we have a relationship, that is parent class followed by a child class. All right. And inheritance uses an extended concepts of child class as well as a parent class. So over here we have various types of inheritance that is available in Python. So that is none other than single inheritance, multiple inheritance, multi-path inheritance, then the hierarchical followed by hybrid. So as we can see here, in a single inheritance, there will be a class A, and from that class, a new class B will be created. All right, it is done. Second type is a multiple inheritance, where a new class is created by multiple base classes. So we can consider class A and class B has a base class or a parent class. Then this class C has a child class. So it is none other than a multiple inheritance. The third one is a multi-level inheritance. What happens here? It is more similar to single inheritance, but we have multiple stages. So that is our third one, multi-level. Next type is a hierarchical inheritance, where we have a complete set of hierarchy for different classes. Clear? So this is class A, then followed by class B and a class C. So there forms a first level of hierarchy. Next, for second level, we have class D and class E, which is completely dependent on the base class of just class A and class B. Clear? Next type is a hybrid type, that is a hybridization of a class formations can be seen in that type of inheritance. Let's see the first one, that is single inheritance. Single, as the name itself says, there will be only one child and one parent that is formed. So we can say that a child class inherits from exactly only one parent class. So that is none other than single inheritance. Let's say an example, class animal followed by definition eats self. What it has to print? Animal eats food. Now let's go with class dog animal, and we are considering bark. It is a property and it is an object that is created. Then what it has to print? It has to print dog barks. Then finally we see that D is been allocated with a object dog of, then D eat, D bark. Thus finally, after execution of this program, at the output we will get that dog eats food and dog barks, right? So this is a single inheritance. Let's move with the next type of inheritance, which is none other than multiple inheritance. So it is very simple. Here we can say that a child class is generated or inherited by multiple parent classes. So we can see here, this is a parent class and this child that is formed is a child class. So we can say that multiple parent class will form a child class. So this is a multi-level inheritance. Let's say an example here, class father defined works self. So it has to print father works. Again, we are creating one more class for mother, class mother def care. So we are defining care self, print mother case. So finally, we are writing child class, class child, father, comma, mother, pass, C equals child, C dot work, C dot care. So who will work? Father. Who will care? Mother. So all the properties of father, mother will be inherited for this newly created child class. So after execution of this program, at the output we can see that father works and mother cares. So this is nothing but a multi-level inheritance. The next type of inheritance is none other than multi-level inheritance. So under this, what happens? There will be a chain that is created. A class will moves on inheriting with its parent classes. So a newly formed class will look like a chain, formation of chain. So for example, we can see here multi-level. The first level will be a grandparent, next level will be a parent, and a newly formed class that can be considered is a child class. Okay, so this is a child-like structure that can be formed by this kind of inheritance properties. Okay, so this is none other than multi-level inheritance. Let's see an example for this multi-level. So we are dealing with a class grandparent followed by show self, defining show self. Then again it has to print a grandparent. Next, one more class is created with a parent. And what is the parent class for parent? It is none other than grandparent. Again we are defined show to of self followed by print parent. Then a new class is created again followed by child class name, and for this child, what is the inheritance? The parent, correct? Next, define show of self, print child. Next, we can step with defining this objects, that is C equals child, C dot show 1, C dot show 2, C dot show 3. And after execution of this program, at the output we will be getting grandparent followed by parent and then a child. Okay, let's move with the next type of inheritance, that is none other than multi-path inheritance. Here we can see that in multi-path we have a various class with multiple paths. But out of these classes, we can coin a common thing, that is all the classes will share a common parent class. Okay, so that is the main thing to note over here, that is under multi-path inheritance. This is the representation of multi-path inheritance. Thus we can say that this creates multiple paths through which the child class can access the attributes or methods from its top level grandparent classes. So this is all about the multi-path inheritance. So these are the types of inheritance that is available for your syllabus. Okay, so this completes our unit, that is unit 3. So in our next session, we will be starting with unit 4, which is all about the graphical user interface, that is none other than GU interface. We will be studying the Tinker module as well as windows and widgets, the layout management, and pack, grid, and place interfaces in our upcoming session. So this was all about today's session. Thank you.